Let's go over a couple of problems for quiz 4. In question 1, we're asked to use long division to divide x minus 2 into this polynomial, and then we'll state the quotient and the remainder. So for long division, I'll rewrite this problem as x minus 2, and this is divided into, so we have x to the fourth, and we have minus 2x cubed plus x squared plus 2x plus 1. Had we been missing any exponents from 4 all the way down to just this constant, we'd have to include a 0 times x for that power, but none of them are missing. I want to first start by canceling this x to the fourth. What do you multiply x by to get x to the fourth? X cubed. I put that above the x cubes, which go here. I then take this x cubed and I multiply it to the x, and also this minus 2. X cubed times x is in fact x to the fourth, and then we get minus 2x cubed. Now we subtract what we put here from what is above, so we get minus x to the fourth, and we get plus 2x cubed. I'll put a circle around these to indicate that I changed their signs. And when we subtract these, you actually get 0. Now we bring down the x squared. Now the next spot we move to is the x squareds. But if you take an x squared and multiply it to an x, you get an x cubed, and we canceled all of those. So we actually don't need to put anything here. Just we have a placeholder. I'll put plus 0x squared. Technically, there are none. So basically, we're skipping over dealing with this spot here. In fact, I'm going to go ahead and just erase this and that. I'm now going to bring down the plus 2x. Our goal now is to cancel an x squared by multiplying something to x. Well, x times x gives us x squared, so I'll put a plus x here. X times x is x squared. And x times a negative 2 is minus 2x. Now when you subtract these, that means you are really changing the signs on both of those. X squared minus x squared is 0, and 2x plus 2x is 4x. And I bring down the 1. We are at our last step. I want to cancel a 4x. I have an x here. That means I have to multiply by a plus 4. So we have 4 times x, which is 4x. But then we also have 4 times this minus 2, which is minus 8. Since we're subtracting this thing, that becomes negative and this becomes positive. The 4x's cancel, but we have 9 that's left over. And this is where the process ends. So what is the quotient? Okay, that's going to be this thing up here. I'm not going to write down this part, this 0x squared. It's really redundant. So I'll just put x cubed plus x plus 4. That's the quotient. And what is the remainder? That is simply the number 9. So I found the quotient and the remainder by using long division. Let's find the horizontal and vertical asymptotes of this rational function. To find the horizontal asymptotes, we can actually look to the highest powered x terms in the numerator and the denominator. I see the highest powered x's as an x squared over an x squared. When this happens, we can use the following fact. The horizontal asymptote is going to be the ratio of the numbers in front of the highest powered x terms. It's of the form y is equal to, in the top we have a 5x squared, in the bottom we have a 1x squared, and that ratio is 5 over 1, or simply y is equal to 5. That is the horizontal asymptote. To find the vertical asymptotes, we look for division by 0 to start with. So for the next part, for the vertical asymptotes, what we're going to do is we're going to take the function itself, and we're going to factor it. I'm actually going to factor both the numerator and the denominator. In the numerator, you can take an x out from both terms, and what is left over is 5x minus 7. If you factor the denominator, it should factor into two pieces. We have an x and an x. It has to be a positive and a negative. To multiply to negative 18, we could use 6 and 3. So I think it's going to be positive 3. Sorry, I don't think that's right. I think it's going to be positive 6 and negative 3. The sum of those two numbers is positive 3, and the product is negative 18. This means we have two candidates for vertical asymptotes. That's going to be x is equal to negative 6, and also x is equal to positive 3. The reason is those numbers make the denominator equal 0. You put a 3 here, that's division by 0. You put a negative 6 here, that's division by 0. For these to be vertical asymptotes, it must be that the numerator is not 0 at these two numbers. Well, the only two numbers that make the numerator 0 are 0 itself and 7/5. And neither of those are 0 or 7/5. So in fact, this is a vertical asymptote, and so is this. It's important to note that we're looking for places where the denominator is 0 and the numerator is not 0, and these two numbers work. To solve this quadratic inequality, I'm actually going to focus on not the inequality, but the equation. Where does x squared minus x equal 90? From this, we can get the answer for the greater than. To solve this equation, I'm going to subtract 90 from both sides, and then try to figure out where x squared minus x minus 90 is equal to 0. I believe this factors... Okay, so two numbers that multiply to a negative 90 yet add to a negative 1. So we have a positive and a negative. I think it's going to be positive 9 and negative 10. The product is negative 90 and the sum is negative 1. That means x is equal to negative 9 and x is equal to positive 10 are solutions to this equation. And if you think about those on a number line, so here's a number line, the equation is true at negative 9 and at positive 10. But that's not what we're looking for. We're looking to see where this function, x squared minus x, is greater than 90. Or said another way, where is x squared minus x minus 90 greater than 0? When does this happen? Well, there's only three things that we have to check. We have to check this region, and this region. We want to include all of the intervals that make this thing true. The approach I like to take is pick a number in each of these regions. So negative 10, an obvious choice would be 0, and then perhaps over here I'll choose 11. I'm going to take these numbers and put it into this inequality here to see if it makes it a true statement or not. So I think I'll start with negative 10, and I'm going to put it into this inequality. So is it true that negative 10 squared minus negative 10 minus 90 is greater than 0? Is that a true statement? Well, that's 100. That's really plus 10 minus 90. Is that greater than 0? And the answer is yes. If you have 110 and you subtract 90, that means you have 20 left over. And this is a true statement. Since negative 10 works in this inequality, that means all these numbers work. So part of our answer is going to be everything from negative infinity up to and not including negative 9. Okay, what about 0? Does 0 work? I'll check that one. So is 0 squared minus 0 minus 90 greater than 0? This is minus 90 greater than 0? No. So I don't want to include any numbers from here. So this one was good. This region was not. What about 11? I'll check that one as well. Is 11 squared minus 11 minus 90 positive? 11 squared is 121. Minus 11 minus 90. Is that greater than 0? Okay, 121 minus 11, that's 120 minus 10, that's 110 minus 90. Is that greater than 0? Oh, that's the same thing as last time. That's 20. And that's true. 20 is greater than 0. So this region works as well. That means I want to include this region, and I want to exclude all of this stuff. I'll express my answer as follows. It's everything from negative infinity up to and not including negative 9, and then everything from 10, not including it, up to positive infinity. For any quadratic inequality, it's typically either everything that's in between your two solutions or everything on the outsides of your two solutions. And you just have to check by using a few numbers to determine which it is.